Hey guys, Cliff the Lazy Geek here, and today we're going to use free software to do the full-fledged processing on an image I got of the Dumbbell Nebula, or M27, recently. And so I used free software to capture that image using Nina. I used free software to guide on that image using PhD2. I am now going to use free software to stack all of those frames together using DeepSkyStacker. I'll then use free software to process those stacked images using Siril and also potentially GIMP and maybe even Starnet++. So tons of stuff that is possible with free software. We're not going to get a result that would be as good as with a paying solution like PixInsight from experience, but we should still be getting something that is quite decent. So let's get started, shall we? So we'll start in DeepSkyStacker. And in DeepSkyStacker, what I'm going to do is that actually I have a complicated scenario in that I have two filters. One is called H-alpha, the other is called oxygen 3. And with those two filters, I can actually combine them in the end to obtain a result that is fairly close to the true colors of M27, the Dumbbell Nebula. The only reason I am using those H-alpha and O3 is simply because from here in Tokyo, it's more efficient. So that means that some of the steps in there are more complicated than a typical one-shot color workflow. And so you can simplify the workflow that I'm doing here. Here you're basically seeing the most complicated scenario. So let's get started. So first I'm going to open picture files, and that will be opening my light frames. We're going to start with oxygen 3 frames. So I'll just select everything that is oxygen 3 in here. And I will want then to get dark files. And my dark files, they're in this dark folder, and we're going to get, I have both 300 seconds and 180 seconds frames because I changed my mind midway. So I am going to select all of my dark files. We also need some flat files. So I need the flat files for my oxygen 3 filter because you need your flat files per filter. And I am going to open that. And I also use dark flat files, and for that they're basically dark frames that are the same length as the flat frames. And I'm going to validate that. And this will let me stack all of the images that I have. Now my M27 images, they're really, really bad in that there was a lot of wind when I took them. There were many clouds streaming by, so we're not going to get the best result possible, but you know, it's still a result. And by the way, I might actually just put all of those frames in a Google Drive and put the link in the description down below if you want to try. Otherwise, at least I will put the stacked frames that we have for both H-alpha and oxygen 3 so that you can follow along for the post-stacking part of this. So what I want to do is use Control-A to select everything. Then I will be right-clicking and then click on Check. Of course, I could be checking frame by frame and then basically excluding myself the ones that I don't like, but I have several hundreds of frames. I'm far too lazy for that. And really, honestly, I should be picking them frame by frame, but yeah, I'm too lazy. So I'm not going to get the best result that is humanly possible, but I am going to get a result. And then I will also set a reference frame. And I'm going to select the one at the top here, and I'll make sure to use that reference frame when I stack my H-alpha frames as well, so that everything is properly aligned together. So I'm going to right click and put use as reference frame. And then I can go and register the checked pictures. And I'm going to select the best 70% of pictures simply because I know many of them are bad. So I put 70% here. I will register already registered pictures because I've already stacked those in the past. I want to make sure I re-register everything. And under advanced, I will leave untouched because the stars could be detected without issue. And under recommended settings, I will see that, okay, we have proper settings that have been set. I might use these Sigma clipping combination method because I had not super good result with the other one. So we're going to do that. I'm going to look at the stacking parameters and I'll make sure that I use standard mode, which will basically have everything framed by my reference frame. And that is so that I don't need to further align my H-alpha and oxygen 3 stacks in the end when I combine them to get a color image. So let's press on OK and OK. And everything will get stacked. We have a summary that I have around 7 hours and 30 minutes of data in oxygen 3. And we're going to validate that. And DeepSkyStacker will do its magic. And it will display an image once the stack is done. So let's wait for this to be done. Okay, and here we have the stack for the original O3, for the oxygen 3 frames. It doesn't look too bad. We actually see the dumbbell nebula and a bit of the lobes there. The star shapes are definitely not great. You can see the impact of the wind, but meh, you know, that's how things are. So I am going to save this using the Save Picture to file. And we're going to save that, why not, in the pictures folder. I am going to call that O3 from DSS. And there we are. And I am going to save that. And the next step is I'll go back to the picture files, and what I'll do is that I'll remove all of my lights except my reference light that I used. Okay, removed from disk. I am going to keep my dark flats. I am going to remove my flats, because my flats for the oxygen 3 and the H-alpha, they're different filters, but there's the same length. So I can use my dark flats interchangeably between the two. And I would want also to remove the 180 seconds darks, because I do not use any H-alpha with 180 seconds dark in my exposures. So we have removed quite a bit. So we have dark frames, we have dark flat frames, we need to add flat frames, and we need to add light frames. I'm also going to uncheck my oxygen 3 reference frame just to make sure it doesn't get stacked with the rest. So I'm going to open picture files, and we are going to this time search for H-alpha, and I'm going to select everything, validate that, so we'll have all of the H-alpha light frames. And then I'm also going to add my flat files for H-alpha, and same thing, I'm going to search for H-alpha, select everything, validate, and I want to make sure that I select everything except my oxygen 3 frame. So I select everything, right click, check. And then my oxygen 3 frame, I right click and I make sure that it's still used as reference frame. Just because I'm paranoid, I'll just uncheck it and recheck it just to be sure. But otherwise it should have no impact. So we now have our light frames for H-alpha, we have our flat frames for H-alpha, we have our dark frames for 300 seconds exposures, and we have our dark flats for my flat frames. And with that, we can do the same thing again. We're going to register pictures, same parameters as before. I'm going to click on OK. We have 6 hours and 40 minutes of data, and we'll just wait for the software to be done. So see you when it's done. And we're done. We're done for H-alpha as well. Here's the results. So we also have like some nice structure of the nebula, some pretty bad stars, but that's how things are. So I'm going to do exactly the same thing. We're going to save the picture to file, and I'm going to call it HADSS. And just like that, using free software, we've stacked and calibrated, registered our star aligned and stacked automatically everything, and we have 2 images, one H-alpha, one oxygen 3, that we are now going to play with and combine in a piece of software called Siril. Of course, I'll be putting links to all of the software I use in the description down below. So see you in Siril. And we're now in Siril. The first thing I'm going to do is I am going to open the H-alpha file, why not? And we're just going to open that, and I am going to stretch it a little bit because we want the image to no longer be linear when we do a red-green-blue combination, our luminant red-green-blue combination. So what I'm going to do is, before I am going to stretch, I'm actually going to set this to auto stretch to see a bit how the image looks like. And I will do some very slight noise reduction using this Atru Wavelets transform. I'll need to open it, click on execute, and maybe the first plan I'll set it to 0.2, something like that, so that and we can see immediately the effect that this has. And you can see it seems to do a big effect. This is because I have this auto stretch on. If I put it to, yeah, it's difficult to actually see because the auto stretch actually redoes the auto stretching that is allowed by the additional noise reduction. I'm just going to apply that. And we can do the auto stretch. We can see that the background is not really good or anything, so we'll have to play with that. Now I'm going to go back to linear after having done this little bit of noise reduction, and I'm going to do an arcsyn H transformation. And this transformation basically lets me stretch the image without blowing up the core of M27 too much. So I'll put a stretch factor, you know, gradually higher until I get something that I think looks decent in terms of how bright I want the object to be to start with before we do the combination. And I'm going to adjust the black point like that so that I try not to murder the lobes, let's say, of the nebula, while still keeping the background fairly dark, although we'll be able to play with that some more later on. So I'm staying very conservative with my black point clipping here. So something like this, maybe a bit less, is probably okay to start with. And I'll probably start with it like this. And we're going to apply that. And I am going to save this image. I'm going to use this little icon on the top right. We're going to save it, and we're just going to call it H alpha. Without the DSS to say it's from Siril, and we're going to save with the default options. And I'm going to do exactly the same with the Oxygen 3 image. So apply some wavelet transformation, then we're going to apply an arcsyn H stretching, maybe a bit less than that. And I want to make sure that I do not murder the core of the nebula too much, so we can see something. Now, obviously, both images will not have exactly the same average, like at all. So when we do the color combination, it might be a bit of an issue, but hey, we can make it work, and we will make it work. So I'm going to maybe apply it like this. So this is applied. I am going to save the image. And this is saved. Now I'm going to do something a bit stupid. I am going to open both images in DeepSkyStacker and stack them against one another. And the reason is, for this particular nebula, both Oxygen 3 and H alpha contain a lot of signal, and I want to create a luminance file that includes both. I could be opening the files in GIMP and then, you know, just basically putting them in two layers and using that. But what I'm going to do is I'm just going to open O3 and H alpha after I clear all of the file list. And now I'm going to open those two pictures, O3 H alpha, and validate that. I'm going to select both of them. We're going to registered, actually we're just going to say stack checked pictures. We're going to say OK. It will stack both of those pictures, which will basically just take the average between the two. Okay, here we are. And I am going to just, once the process is done, save the picture to file. And that will be our luminance file. And here we are. So in Siril now I'm going to go into image processing and RGB compositing. This takes a bit of time for the tool to come up, but once it's up, I'm going to select H alpha as my red channel, and I'm going to select Oxygen 3 for both my blue and green channel. And you'll see that they're all properly aligned because I've actually aligned everything in DeepSkyStacker to the same reference frame. There is an alignment method in here, but I find that it works weirdly. It seems to rotate a bit the image, it doesn't provide good alignment, and tends to crash Siril as well, at least in this beta version. Now I want to look at the result. The result looks surprisingly good. We have the actual nebula that's available here. We can see it with its like corkscrew kind of structure there, which is pretty neat. And I might try to add luminance, see what that gives us. And yeah, it seems that, I don't know if it's really helping on us, but let's add it, see what happens. And what I'm going to also do is click on this finalize color balance, which will let me do a color calibration. So to do a color calibration, I can see that my background is kind of red. So I'm going to go into the red image, find an area with not a lot of stars like this, and say use current selection and do a background neutralization. And with that, the reddish tint of the background is gone. So this is before, this is after. Now what I don't like about that is that the corkscrew structure is also slightly affected by that, and it kind of loses a bit of this corkscrew structure, but I guess that's how things are. And the white reference, I am actually going to select one of the stars that looks like it should be white. It's kind of like random on my part, definitely not the reddish stars here, but maybe this one here. I need to use maybe the blue channel, maybe this one actually. And I'm going to say that the current selection is my white reference and apply that. We can look at the RGB image. And we do have still the structure that's there. And we're already starting to get a decent red, green, blue color image of the M27 dumbbell nebula there, which is pretty neat. Now I am going to do a selection there so that we're going to crop a bit to frame back the object itself, and also to remove all of those stacking artifacts that we have on the edges. So I select, right click, crop, and now we have a more centered image. Now what happens if I do an auto stretch? We can see that the auto stretch, we do have quite a bit of detail there, right? This is pretty neat actually. And we can see also that our background is very uneven. And this is exactly what the background extraction tool here is meant for. So we're seeing that the background is kind of all over the place, which means that I will keep this degree order to 4. I'm not going to go into the details, but the higher, the more it can adapt to weird shapes of changes in background color or background intensity. If you see you have a background that's pretty much linear, like it's a gradient that goes from bright on one side to dark on the other and doesn't have a lot of shape, you will want to actually go down to level 1 or 2 in there. It gives better results. So feel free to experiment with that. Then I'm not going to change anything, but I'm going to click on generate, and it will set a list of background samples. And for me, I will want to avoid the samples that are near the nebula itself. So I'm going back to the blue channel where I can actually edit stuff. I'm going to do right clicks nearby the nebula to avoid selecting that nebula at all. And so we can get, a proper background modelization, a background model that does not include the nebula. And something like this is probably fine. Yes. And now I'm going to I'm going to go to the RGB tab, maybe click on apply. And it's not so bad. I think, yeah, this looks okay. We'll be fine. So next thing, I'm actually going to remove the green tint in the background. So I'll go inside remove green noise, click on apply in this tool, and this will remove that green tint, including within the nebula proper. So now I want to stretch that image without being as aggressive as the auto stretch, right? So we could try for some more arcsyn H transformation. I'm going back to linear, and we can have like a stretch factor. Oh, it needs to be really small. Maybe 3? Yeah, it's not going to work very well, is it? I think I need to use a proper histogram transformation. Oh no, we are getting something. We are getting the lobes out, and we're getting even this little part here out without blowing out the background, the core of the nebula too much. We are blowing out the stars themselves, so we'll try to recover that later on. And I'm going to play with the black point to make sure that while we still have a visibility of that kind of like wispy lobes of the nebula, we don't have too much of a bright background. So it's kind of like a pretty, you know, unintuitive, or it's very in the eye of the beholder kind of exercise about how dark the background should be. I typically, personally, do not like it too dark. So I'll probably do something like this. I think this is fine for now. And now we're going to do the local histogram equalization, basically, which should help us get those lobes a bit punchier there. So if you increase the clip limit, you can see that you get punchier lobes, but you can see you can get weird shapes there. And those shapes, you can actually make them change by using those tiles grid size. And you can see with a size of 1, it actually works pretty well for me. And we can see the lobes much clearer than before. Maybe a bit too clearly, actually. And I think something like that is a bit less artificial. We can still see the lobes there. We can still see the nebula. We can see all of that structure inside. We can see like those weird lobes there. We can see a lot of things very well in here, including the nebulosity here without being overcooked, right? So that's kind of like, again, in the eye of the beholder. How much do you want to overcook or cook your image? And I think I'm going to go with this for now. I'm going to apply that, and maybe I can do some curves transformation using this to kind of make the blacks, the blacks a bit darker, like here, as we have it here, where I've managed to extract a lot of the nebula here. And yeah, I think this is actually pretty good. We could almost call this, you know, a final result. But what I'm going to do as well is I'm going to play with the color saturation here. So we're going to go into the image processing, click on, where is it? Color saturation here. We're going to make sure that preserve background is still checked. And first, I'm actually going to increase the color saturation for the blue. And you can see now the blue is much more visible, much punchier, and it actually gives us a better kind of view of the corkscrew structure within the M27 nebula there. And we're really getting a lot of structure, so I'm quite happy to be getting that with this piece of free software from Tokyo. And like all of the software that I've used, except the operating system for now, is completely free and also open source. So I think this is pretty good. We can click apply here, and honestly, I think we could call this a day already. And this is giving us a really nice result. I might want to do another color saturation round where I'll try like maybe orange, brown, yellow saturation to try to see if the corkscrew structure can get more visible. Doesn't seem to be doing a lot of difference. Maybe pink, red, red, orange. No, that is far too crazy. Maybe, yeah, I'm not sure how I can get that corkscrew structure in there. What color would be best selected by that? So I'm just going to leave it be. And now we're going to save that image. Now that image, I'm going to save it as a 16-bit image because I will want to make those stars a bit less punchy. And I have multiple options. Actually, I could actually do it in here using a median filter. And if I set a size like 5.5 and maybe 2 iterations, something like that, then apply to the image, you can see the stars are reduced, but the image itself is a bit blurrier, right? So this is before and after. So it's maybe a single iteration would work well. We can try that. And now we have before and after. This is actually not so bad. I might keep that, and maybe we can clip the blacks a bit more here now that we have more noise reduction that has been done using that median filter, because it really does noise reduction and it has the added benefit of diminishing those stars. And here we are. I think this looks, you know, pretty decent there. And we're going to apply that. And again, we could call this a day. This could be our final image, but I am still going to bring it into both Starnet++ and into GIMP to try to see if there's a bit more things we can do with like curves transformation, for example. So let me save that image. I'm actually going to save it as a 16-bit image. So I'm going to convert it to 16-bit, click on that save button, and I'm just going to call it processed by _Siril, and I'm going to put the file extension as TIFF. Click on save. We are going to use 16-bit unsigned integer and click on save. And now we have saved our image. So next step, I'm going to load it into GIMP and we'll see what we can do. Okay, I'm using the latest version of GIMP, which is 2.10.20, I think, at this stage, and I'm just going to drag and drop the TIFF file. We are going to rotate it or keep the original. I think we're going to rotate. I'm not sure. That could be important in the end, but we'll see. For the moment, we kept the original, I think, or maybe I clicked rotate. I'm not sure. Whatever, doesn't matter that much. And what we're going to do is that we could try to like extract that core a little bit more. So to do that, what I can do is we have layers on the right hand side of GIMP here. And I can right click on there and we can duplicate this layer. So we have duplicate layer, and now we have the identical layer twice. And this I here is say like which layer is visible. So if I click on here, the first layer is invisible, the second layer is, but because they're identical, it doesn't seem to change anything. If I do this, we see the first layer, and anyway, the first layer is above the second layer, so we don't see that the second layer is invisible. If I remove both, we don't see anything. So on the second layer, what I'm going to do is I am going to right click and we're going to add a layer mask. And by adding a layer mask, we're going to keep the default option, which is a grayscale copy of the layer. And I'm going to say add. And what happens is you can see I have this little square here that is highlighted, and this is my mask itself. If I make the second image invisible, we have the mask applied to the first image, this little thing there, and we can see slightly the core of the nebula. And I can adjust that. I could go into colors and curves while I have the mask selected, and do something like a curve transformation like that, so that most of the core of the nebula is then visible. Or I could diminish it to have a low, low power mask as well. So I can do this to have a mask like this with just the core of the nebula. And then I select the core of the nebula and I can select, the actual image on which the mask is applied. And I can go to colors, curves, and I could say that I want to, you see, affect only the core of the nebula, and I want to make the corkscrew structure either more visible by making it less bright, or we want to go for a brighter kind of image. But I want to go a bit less bright, something like that. So I pull the curve down like that, and we can see before, after, the core and the corkscrew structure are a bit more visible. Now this is what we're missing from things like PixInsight, our star tools, our APT. It's like an HDR multi-scale transform that would do that for us and could actually enhance the level of details that we have within the nebula. But still, we can see a lot of the details that are available. We're now able to see even better the corkscrew structure. Everything is nice like that. And that's how you can do masks. So what we did is we had a mask that is a luminance mask. We increased the brightness of that mask so that the center, all of the nebula itself is unmasked, but the background is masked. Then we clicked on the actual layer that the mask applies upon, and we are diminishing the brightness. What that affects this particular layer, but then that layer is superimposed on the layer underneath that is the original image. So if I make it visible, I can see, like, if I have two layers, we have the core that is less bright. If I have only the bottom layer, the core is back to bright. So that's like a very convenient thing to do. Masks are super important and GIMP super useful to do, and you can make a luminance mask super easily like that, completely automatically. And now that I'm satisfied with what I did, I am going to say that I want to merge down my layer so that I have now a single layer with the operation that I have accomplished. I could do that in the end, but I prefer to do that. I don't know, it's personal preference, but it's probably not good practice. But I can merge it down so that we can actually go for all of the changes into a single layer. What I don't really like about that image is that the stars are very bright, very saturated, very visible. I mean, look at this. This is oversaturated. I don't really like that. So how can I change that? Well, I could try making a star mask, but it's relatively complicated to do in GIMP actually. So what I'm going to use is another piece of free software that's also open source, which is Starnet++, to extract an image that does not have any stars in it. So let us do that. And Starnet++ is actually, I have it here. So what I'm going to do is I'm going to save this image. First, I want to make sure that it is indeed 16 bits. I'm going to save as, and we are actually not save as, but we're going to export as. We're going to select a TIFF file, so processed, and now we're going to put GIMP and export that. And we're going to just say export. And now, with that GIMP file that has been added, I am going to copy and paste it into my Starnet Win folder. So this Starnet comes as a zip file. If you unzip it, you get exactly what I have in here. I added processed gimp.tiff, and I'm just going to edit this run RGB starnet.bat to use my processed gimp.gimp. So I'll just have here processed underscore gimp.tiff. And the result will be processed underscore gimp underscore s for stars .tiff. And I'm going to save that. You can actually make it so that you can drag and drop the image on the file, but I'll just do this. And only 16-bit color RGB images are supported. So this is something else. With the creation of the mask, I added an alpha channel. And we need to actually remove the alpha channel. And alpha channel is a transparency channel, and it doesn't work with Starnet. So in GIMP, I did right click and I said remove alpha channel. Now I'm going to export the file again using the same name. We're going to replace it and export it. And now we are going to, again, I want to make sure that it's displayed properly. Yes, it is. I'm going to go back to pictures, Control C, Control V, and now we should have a file that has the proper format for Starnet++. So I'm going to double click, and here we are. Starnet is working, and it's going to make a starless image, which I'm then going to import back into GIMP, and you'll see how I use it. Okay, and here we are. We have an image of the nebula without stars. It looks ugly, but that's what we're going to use now in GIMP. So I am actually going to open that image as a layer, right? So I am going to go inside Pictures, and we're going to go to Starnet Win and the one without stars. And what we can do is actually make its opacity, change its opacity until we get like more understated stars. They're not quite, desaturized, but you can see we can make them. So we have the top layer is the Starnet layer, And the bottom layer is the non-Starnet layer. And by playing with the opacity here, I can make the stars slowly disappear, I can make them reappear, but I can definitely make them less obvious in the image so that, you know, we are more focused on the actual nebula. And if I go down one level below, I can go into the saturation of my underlying image. And I could say that I do not want to saturate that much. Right, so we could have something like this, and the stars now are much less saturated than they were just a moment ago. So that is one way of doing things, and you know, it works pretty well. I'll bring them back a little bit like that, and maybe saturate a bit less. Something like this, and now the stars are much less saturated, they're much more pleasing to the eye, at least to my eyes. This is all very subjective, and we've diminished them a little bit. Now, this is my own little way of doing things. I'm sure other people have much better ways of doing that, but this works, you know, reasonably well for me. And I think as it is right here, it works pretty well as a final image. I'm actually quite satisfied with what I'm getting like this with just free software. So we used free software to capture the image. We used free software to stack the image. We used free software to process the image, to remove stars, to play around. And all of those are free as in beer and free as in speech, meaning they're both free in terms of a financial value. You don't need to purchase the software. They're also free in terms of the fact that they are open source. And so this is great. I really like this option, and I hope you enjoyed following along this tutorial. I'll make sure to put the links to all of the software that I have in below, and I will also post links to my data files, at least the stacked ones, so you can follow along for Siril, GIMP, and Starnet. And with that, that's pretty much it for this video. If this kind of video about astronomy, astrophotography, tips and tricks, gear reviews, all that kind of stuff, if that's interesting to you and you are not subscribed to this channel, first, welcome to the channel. Feel free to go down below, click on that subscribe button, click on that little notification bell, because I think this channel is just for you. And you know, otherwise, as always, feel free to go down, click on that like button, leave a comment down below if you have any suggestions, tips and tricks, that kind of stuff. Because, you know, I don't know everything, like very far from it. So I'm always learning something new, and a lot of your comments have taught me a lot. And it's absolutely amazing. So thank you so much for that, and keep them coming. And you know, with that, thank you so much for watching. Don't forget, whenever you can, to look up at the stars, and I'll see you next time.